All right, hello everyone. My name is George, and we will be going over question 5 from midterm 1 of CS61B Spring 2020. And so this question is mainly an extension or something to think about outside of Project Zero signpost. And so the question says, we would like the ability to compare two square objects as in Project Zero. Consider the implementation below, which defines SQ as implementing the comparable interface. So it also tells us each line of code that might contain a bug has a blank line underneath. So that means this line right here, we would fill it in if we think the line above it, this one, has a mistake or a bug. And then, so that's what the rest of it says. We want to use the non-generic definition of comparable from lecture rather than the newer improved comparable with generic type T version. So what that basically means is in this comparable interface that we were defining in lecture, it has a compare to method that specifically takes in objects. So that would be public int compare to, and then with objects. So like that. Ooh, a little tight, but yeah. And so knowing this, let's get started with our square class. So we want to be able to compare two square objects with compared to. So if you remember from lecture, this compared to right here takes in an object, not a specific class. So if you look at the first line in this question, we already can see that this is not the compared to that we want. We want the compared to that compares objects. So we can fill this first line in with public int compare to, and we want to pass in objects. We want to pass in an object S1. All right. So now that we've done that, we are looking at the next line. Well, now that S1 is no longer of square or SQ class, it is an object class. For this next line to work, we must cast S1 to a square object so that we can set other equal to it. So this line will now follow as SQ other equal SQ S1. All right. And then finally, we want to return this dot group size minus other dot group size, which compares the current group size with the other group size. If the current group size is bigger than others group size, then we will be returning a positive number, right? So if this group size right here is bigger than this group size, we'll be returning a positive number, right? And that is precisely what we want, right? Returns a negative number if S1's group is shorter than S2's group. So if S1, so that's this, if this group is shorter than S2's group, that means the first number is less than the second number. We want to be returning a negative number. So this line does exactly what we want it to do. Now we want to be looking at group size, which is the more bulky part of this question, right? And there are a couple things to understand, really, to understand group size. And those are defined at the bottom right here. And these are also for Project Zero. So if you remember doing Project Zero, these may seem familiar to you. So the first one is head. Head is the first square in a currently connected sequence of cells, right? So if I have 4 squares, so let's call them like S1, S2, S3, and then S4, and they're connected like this. That means the head for this entire sequence, underscore head, is this S1 square, right? That is the first square in the sequence. And all 4 of these squares have head S1. The next variable that is going to be useful is group. So if we read the comment for group, it says a group number of the group of which this is a member if head equals this. So this condition of if head equals this is kind of like the key for this variable, as in only the head of a sequence keeps the group number if this is unnumbered. And we'll see that as we continue on with the comment. It then says number sequence have group number 0 regardless of value of group. So the group variable doesn't matter for numbered sequences, so if your sequence number is not 0. And then unnumbered one-member groups have a group number of -1. So if you're by yourself and you are unnumbered, then you have a group number of -1. And then finally, if head is not this, so if you are one of these 3 squares, right? Your head is not yourself. The square is unnumbered, which it is in this case. We're going to assume S1 through S4 are unnumbered. Then group is undefined, and the squares group is maintained in the heads group, which means that this underscore group for these three squares is undefined. And we want to use the heads group to figure out the group number for these. And then finally, there's has fixed num if the square has a fixed number, and then sequence num. If this square has a sequence num, it wouldn't be 0. If it doesn't, then it has a sequence num of 0. And so these are just refreshers from the project. Now to jump into the question, we want to do group size, right? So if we look in the comment above, it says numbered squares have group size of 0. And that's the first check, precisely. So if sequence num is not 0, so if sequence is not 0, that means this square is numbered, and therefore the entire group that this square is a part of is also numbered. So numbered squares have a group size of 0, and this is precisely what we want. So this is good. Next, else if underscore group is -1. So if we examine this and we recall what we talked about with only the heads group being the one that matters, if we were to call group size, say on any of the squares here from S2 to S4, then this underscore group, remember, is undefined, even though they are part of the same group that S1 is in, which means that to check groups, the group number for all squares, we want to use the head. So we would fix this line with else if we want the heads dot underscore group equals -1, which means it's by itself. And then if it's by itself, we know its group size is 1, so that's why we return 1. Yes. Now we move on to the final part of this. We want to check if there's a mistake or not. So we start by initializing count to 0 right here, and we start looping. For square L and is this, L.successor not null, L equals successor dot successor. So let's just walk through this example, say with our current S1, S2, S3, and S4. So if we call group size on S1, so that would mean L would point to S1 to begin with, and count would be initialized to be 0. So if we start walking through, we check S1. S1.successor is not null, so we go into the for loop, and we can update count from 0 to 1. And then we run the L equals L.successor, so L is no longer S1, L is S2. And then we check the condition again, L.successor not null. Well, S2 successor is not null, we know that it's S3. So we go back into the for loop, count goes from 1 to 2, and then we update L again. So we set S2 equal to, or L equal to S3, and we check the condition again. L.successor is not null, right? Because after S3, the successor of S3 is S4. And so we go into the for loop, we increment count from 2 to 3, and then we update L from S3 to S4. And then we go through our conditional check, and we see L.successor is not null. Well, the successor of S4 is actually null in this case. So this would end our loop, and we would return whatever we got for count. But as we notice, our count is 3. But visually, we can see that our group has a group size of 4 instead of 3, which means that we were 1 short in our iteration. We should have counted, we've counted 1, we've counted 2, and we've counted 3, but we have not counted 4. So that should lead us to believe that our conditional check should not be L.successor is not null, but something that would allow us to check S4. And so after S4, L is null. And then if we had run the iteration of the for loop with S4, we would update 3 to 4, and then L is null, and that's when we want to stop. So that will lead us to believe that our conditional check should look something along the lines of L is not null. So this is something we should keep in mind, just from looking at that. Now, let's say, what if we didn't choose S1 to be the group size? What if we chose, say, like S2 right here, or S3, or even S4 to be our group size? They should all return the same group size, which is 4. But if you do, for simplicity's sake, let's start at S4. So if we use S4 as this, L starts at S4, count starts at 0. And if we add our new updated condition to our for loop, we'll see that S4 is not null. So we go into our for loop, count goes from 0 to 1, and then we update S4 to null, and then we terminate our for loop. And we see that if we called group size on S4, we would get 1, which is not what we want. We want 4. And so one thing you'll notice is that this for loop right now depends on what is calling group size. It'll start counting from that point onward. And that is not what we want. We want to start from the very first square of our sequence. And if you recall the different variables that we have, the very first square of our sequence is saved in the head. So if we change the initialization of square L to not equal this, but actually to equal the head of what we are, of our sequence, then we will start from the head and we'll go all the way to the end, which is null. And we know that L equals L dot successor is what we're looking for, so that would result in changing this for loop to be square L equals the head, L not equal to null, and L equals L dot underscore, underscore successor. Yeah, and so that concludes question 5. So there were, to reiterate, the bugs that we wanted to catch were in the first part for compare to. Remember, the compare to, or the comparable interface that we learned in class, in lecture, takes in an object, not a square or any other class, right? It takes in an object, right? So we have to change our compare to, like right here, to take in an object. But now that S1 is of static type object, we must also, in turn, by changing this line up here, we must also change this line so that S1 can be casted to a square so that we can set it equal to other. Then bugs in group size, remember the head of the sequence is the square that keeps the group number. So that's why we have to use head right here, and we can't just call underscore group. And finally, the for loop that is currently provided for us starts at this when we should be starting at head, and L dot successor not null does not actually count the last square. So that's why we want L not null.